Audicate. Listen and learn.
Welcome students, today we are going to learn Chemistry, Part 2, Textbook for Class 11, Chapter 8, Redox Reactions. Where there is oxidation, there is always reduction. Chemistry is essentially a study of redox systems. Objectives. After studying this unit you will be able to identify redox reactions as a class of reactions in which oxidation and reduction reactions occur simultaneously. Define the terms oxidation, reduction, oxidant, oxidizing agent, and reductant, reducing agent. Explain mechanism of redox reactions by electron transfer process. Use the concept of oxidation number to identify oxidant and reductant in a reaction. Classify redox reaction into combination, synthesis, decomposition, displacement, and disproportionation reactions. Suggest a comparative order among various reductants and oxidants. Balance chemical equations using 1. Oxidation number, 2. Half reaction method. Learn the concept of redox reactions in terms of electrode processes. Chemistry deals with varieties of matter and change of one kind of matter into the other. Transformation of matter from one kind into another occurs through the various types of reactions. One important category of such reactions is redox reactions. A number of phenomena, both physical as well as biological, are concerned with redox reactions. These reactions find extensive use in pharmaceutical, biological, industrial, metallurgical, and agricultural areas. The importance of these reactions is apparent from the fact that burning of different types of fuels for obtaining energy for domestic, transport, and other commercial purposes, electrochemical processes for extraction of highly reactive metals and nonmetals, manufacturing of chemical compounds like caustic soda, operation of dry and wet batteries, and corrosion of metals fall within the purview of redox processes. Of late, environmental issues like hydrogen economy, use of liquid hydrogen as fuel, and development of ozone hole have started figuring under redox phenomenon. 8.1 Classical idea of redox reactions, oxidation and reduction reactions. Originally, the term oxidation was used to describe the addition of oxygen to an element or a compound. Because of the presence of dioxygen in the atmosphere, approximately 20%, many elements combine with it, and this is the principal reason why they commonly occur on the earth in the form of their oxides. The following reactions represent oxidation processes according to the limited definition of oxidation. 2Mg, solid, plus O2, gas, produces 2MgO, solid, equation 8.1. S, solid, plus O2, gas, produces SO2, gas, equation 8.2. In reactions 8.1 and 8.2, the elements magnesium and sulfur are oxidized on account of addition of oxygen to them. Similarly, methane is oxidized owing to the addition of oxygen to it. CH4, gas, plus 2O2, gas, produces CO2, gas, plus 2H2O, liquid, equation 8.3. A careful examination of reaction 8.3, in which hydrogen has been replaced by oxygen, prompted chemists to reinterpret oxidation in terms of removal of hydrogen from it, and, therefore, the scope of term oxidation was broadened to include the removal of hydrogen from a substance. The following illustration is another reaction where removal of hydrogen can also be cited as an oxidation reaction. 2H2S, gas, plus O2, gas, produces 2S, solid, plus 2H2O, liquid, equation 8.4. As knowledge of chemists grew, it was natural to extend the term oxidation for reactions similar to 8.1 to 8.4, which do not involve oxygen but other electronegative elements. The oxidation of magnesium with fluorine, chlorine and sulfur etc. occurs according to the following reactions. Mg, solid, plus F2, gas, produces MgF2, solid, equation 8.5. Mg, solid, plus Cl2, gas, produces MgCl2, solid, equation 8.6. Mg, solid, plus S, solid, produces MgS, solid, equation 8.7. Incorporating the reactions 8.5 to 8.7 within the fold of oxidation reactions encouraged chemists to consider not only the removal of hydrogen as oxidation, but also the removal of electropositive elements as oxidation. Thus the reaction 2K4 FeCN6 aqueous plus H2O2 aqueous produces 2K3 FeCN6 aqueous plus 2KOH aqueous is interpreted as oxidation due to the removal of electropositive element potassium from potassium ferrocyanide before it changes to potassium ferricyanide. To summarize, the term oxidation is defined as the addition of oxygen or electronegative element to a substance or removal of hydrogen or electropositive element from a substance. In the beginning, reduction was considered as removal of oxygen from a compound. However, the term reduction has been broadened these days to include removal of oxygen or electronegative element from a substance or addition of hydrogen or electropositive element to a substance. According to the definition given above, the following are the examples of reduction processes. 2HGO, solid, on heating produces 2Hg, liquid, plus O2, gas, equation 8.8. Removal of oxygen from mercuric oxide. 2FeCl3, aqueous, plus H2, gas, produces 2FeCl2, aqueous, plus 2HCl, aqueous, equation 8.9. Removal of electronegative element, chlorine from ferric chloride. CH2 double bond CH2, gas, plus H2, gas, produces H3C minus CH3, gas, equation 8.10. Addition of hydrogen. 2HgCl2, aqueous, plus SnCl2, aqueous, produces Hg2Cl2, solid, plus SnCl4, aqueous, equation 8.11. Addition of mercury to mercuric chloride. In reaction 8.11, simultaneous oxidation of stannous chloride to stannic chloride is also occurring because of the addition of electronegative element chlorine to it. It was soon realized that oxidation and reduction always occur simultaneously, as will be apparent by re-examining all the equations given above. Hence, the word redox was coined for this class of chemical reactions. Problem 8.1 in the reactions given below, identify the species undergoing oxidation and reduction. 1. H2S, gas, plus Cl2, gas, produces 2HCl, gas, plus S, solid. 2. 3Fe3O4, solid, plus 8Al, solid, produces 9Fe, solid, plus 4Al2O3, solid. 3. 2Na, solid, plus H2, gas, produces 2NaH, solid. Solution. 1. H2S is oxidized because a more electronegative element, chlorine, is added to hydrogen, or a more electropositive element, hydrogen, has been removed from S. Chlorine is reduced due to addition of hydrogen to it. 2. Aluminium is oxidized because oxygen is added to it. Ferrous ferric oxide, Fe3O4, is reduced because oxygen has been removed from it. 3. With the careful application of the concept of electronegativity only we may infer that sodium is oxidized and hydrogen is reduced. Reaction. Third, chosen here prompts us to think in terms of another way to define redox reactions.
Audicate. Listen and learn.